Okay, so section 3.6 was all about functions. And what we said about functions were start out with a relation. Basically, a relation is a set of ordered pairs. This is a relation right there. Now, each relation has an x and a y, an x and a y, x, y, x, y. That's what we said about it. So if I was to annotate this a little bit, see if I can do it. X, y. And again, labeling points is it's just a good way of keeping things straight in your head. You don't have to, but it's a good idea. So you should probably do it. You should do good ideas. Labeling things is a good idea. So you should do those. All right. But that's one thing I said you could do, just because it's just a good idea. All right. And because we said that, I will pass all that. Go past all that. We said we can decide what the domain and range of something is. So again, if we just kind of like, again, I'm just going to kind of x, y, the domain are the x values. What are the x values? Well, this one, and this one, that one, that one. Ooh, yeah, and that one. Okay. Those are your x values and those are y values. What's your range? Well, your range is just that, 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 and that. So you have a domain, you got a range. All right. X's and Y's. Again, not trying to make it complicated. That's how it works. X's, Y's. So in this case, the X values are 0, 1, 2, and 3. The Y values are 0, 8, 6, 16, and 24. Okay. Yeah. I'm not going to belabor that. I think you can get that pretty quick. All right, I'm going to go past all that. Cool. All right, there are two tests that we use to determine whether or not things are functions. Here are the two tests. Do we have repeated x's? If any x shows up more than once, it is not a function. So if any x shows up more than once, it is not a function. So here, I have a 1 and another 1. That's an x equals 1. That shows up more than once. It's not a function. That's it. All right. All right. The y's can show up as much as they want. We can have many. The y's you can only have one y. Or you can have a 1, 7, 2, 7. I don't care that the y's show up more than once. All I care about is the x's. The x's don't show up more than once. It is a function. That's the first test. All right. The second test is called the vertical line test, or the pencil test. Basically, you draw a line through the function, and you see, does it go through it more than once? Yes. Yes. It hits here and there. It is not a function. It's very important that you don't get those two confused. I noticed that some people got those two things backwards. The the way we know that it's not a function is by saying, okay, if it goes through it more than once, if it goes through it more than once, it is not a function. So we can go to the next one. Let me clear all these. Come on. Going slow. Ooh, all right. And how does it pass through? Once. How about here? Once. How about here? Once. So as you can see, any line that we draw that goes straight up and down is only going to go through it one time. So that means it is a function. That's it. All right. That's your whole criteria. Don't overthink it. Just make sure you keep it straight. Is basically is all you need to do. All right. Then we got to evaluating functions, which is plugging stuff in. I'm not going to belabor that too much. If you're good at that, good job. I'm happy that you're good at that. If you're bad at it, that's not good. You should get better at it if you want to pass this class, essentially. So it's really just, and again, I pointed this out earlier. This is really important. If you're going to be doing any more math, if you're going to go into nursing, if you're going to go into the sciences, if you just want to become a math major, this is going to show up over and over again. You got to know how to plug stuff in. You don't know how to plug stuff in, you're going to have a really hard time. So this is one of those kind of skills that's just like, you got to know how to do this. All right, so I'm not going to go through all that. Notice I put everything in parentheses. Parentheses, 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 parentheses. That's the biggest thing that students mess up is they don't get their parentheses right. Make sure you do your parentheses correctly. That takes practice, but you can do it. All right. Summary of that. Okay, that's fine. You guys got that. Let me make new share. All right. Just the. Okay. Then we jump into 5.2. In 5.2, we have what we call Intro to Polynomials. So a whole different other section. We basically said a polynomial is split into terms. A variable is just a letter. A power is just a power. I mean, an exponent is a power. A degree is the largest power of a polynomial. That's what we said. All right, these are all polynomials here. This is a term, but a term can be split into 3 different parts, namely a coefficient, a variable, and a power. So we just said there are 3 parts to it. Okay. We described what an exponent is. I'm kind of going through this pretty fast. So if you're trying to like copy things down, just copy down what you think is important. But basically, I explained what an exponent is. The biggest thing that I wanted to say about this is if we have 2 to the 5th, that does not equal 10. So 2 to the 5th, let me just write this out because I really want to say this. Does not equal 10. One of the common mistakes that students make. Now again, this is just because you haven't done a whole bunch of this. So you just kind of are going off the first thing you think in your brain. Right? You're using the common sense. There's math common sense, and then there's other kind of common sense. You're using regular common sense. We got to use math common sense. So math common sense tells us that 2 to the 5 is 32. Now, the first thing you might think is, well, 2, 5, 10. That's not what's going on. This is really important that you don't do that. All right. What you need to do is do, ooh, that was bad. Let me clear that. That was embarrassing. That's fine. That 2 to the 5th is 2 times 2 times 2 times 2 times 2 times 2 are 32. So an exponent just tells you to multiply by itself a whole bunch of times. All right, and that's important. We'll get to that in a second. There we go. All right, invisible one, we talked about coefficients, monomials, binomials, trinomials, polynomials. I'm not going to go into that too much. You can figure that out. The degree of a polynomial is its highest power. Yeah, I'm not going to. You can read that slide. That's not the difficult part. All right. Again, I did like a really quick overview of that. Barely went through it, but that's all stuff you can read and look at, and you can kind of figure out. It's just terminology and stuff. All right. Today, the basic meat of what we're doing is going to be this right here. And I actually work a few examples just to show you how they work. But we're going to begin with adding and subtracting polynomials. So again, I'm defining a polynomial just so you can continually have that in your mind. What are we talking about? What is a polynomial? Well, I'm defining it. So there's your definition of a polynomial. All right. Again, terminology. I'm giving you more, I'm making sure that you know what the words mean. What is a term? So you can look at that later. What is a term? All right, so now that you have those, you have a coefficient, a variable, and a power. All right, like terms. I'm going back over this again because it's super duper important. Like terms have the same variable raised to the same power. So x to the 1 power are just x, and x are like terms. A squared and a squared are like terms. I can add and subtract those. So this plus here is something that I can do. That minus there is something that I can do. If these were like this, x and a, I couldn't do it. I just can't. I might want to, but I can't. I cannot add 2x and 19a. It doesn't make any sense. I can't do it. It's impossible. All right. W and w squared, even though they both have a w in them, I cannot subtract those two terms. Now, we're going to get to multiplying terms, and this will get a little bit confusing when I start talking about it. But I just want you to notice that the operation of addition and subtraction for those two terms can only be done if you have like terms. These terms are like terms. These terms are unlike terms. Even though they both have the letter A, they are unlike terms because one has a 2 and the other has a 3. Now, I definitely can't do this. This is something students love doing. 8y plus 5, students love adding together 8y plus 5. They love doing it. You can't do it. Even though you really want to, you cannot add 8y plus 5. You can add 8y plus 5y. That's perfectly acceptable. So this is what you can do. This is what you can't do. We cannot say 8y plus 5 and smash them together into 13y. Students love doing it. They do it all the time. You'll probably do it at some point. You still can't do it. So it's one of those things that's kind of like illegal in math. We have all these little rules, and there are rules and things you cannot do. All right. Again, unlike terms just means that they have different variables or different exponents. I'm not going to go through it too much. Cool. All right, combine like terms. When we have too much stuff, we put it together. You can only combine like terms. So for example, you can add 4x and 5x. You cannot add 4x and 5y. It doesn't make any sense. You cannot add 4x and 5x squared. You can't do it. Now, how do you combine like terms is the question. Sorry about that. How do you combine like terms is the question. Well, you add subtract the coefficients. Now, you need to know what coefficients are. All right, coefficients are the front numbers. 4 and 3 are the front numbers. You add those together, you keep the variable and the power the same. Let me show you. 3x plus 7x. 3 plus 7 is 10. 10 what? Well, here's what you want to do. Or here's what a lot of students think, okay, I got an x, another x, it's gotta be x squared. Got it. No, you don't got it. 3x plus 7x is 10x. Not 10x squared, but just 10x. So 3x plus 7x is 10x. Now, you're going to have to absorb that. That will not necessarily make sense to you automatically, but you're just going to have to accept that that's how we do that for a little bit. All right, 6x squared minus 5x squared. So 6 minus 5 is 1. Okay? So 6x squared minus 5x squared gives me 1x squared. Not 1x to the 4th, not 1x to the 0, 1x squared. We keep the variable and the power the same when we combine like terms. All right, let's look at this example here. 9x plus 7x squared. Can we add those together? Now, we can't. We really want to. I would love to say 9 plus 7 is 16. Can't do it. Why? Because they are not like terms. They are unlike terms. You cannot add or subtract unlike terms. You literally cannot do this. So the answer is just write the same thing because you can't do it. You literally cannot do it. All right, 8x minus 7y. I want to subtract those. So my thought process might be, well, 8 minus 7 is 1. Then I'll pick the x or the y. I'll pick one. You can't do that. You can't actually subtract those. It's literally impossible. You cannot subtract 8x minus 7y. You just can't do it, even if you want to. All right. So I just kind of did an example here and just showed you the same thing. You see how w cubed here? W to the 3, w to the 3, w to the 3, w to the 3. So you can kind of see how that works. I'm not going to belabor that point too much. This is very important, actually, though. I'm trying to show you how simple it is. All right. You see how the front number changes? 1, 3, and 4 gives you 8. And y to the 3, y to the 3, y to the 3, y to the 3. Another thing I want to point out is, notice this right here. I have y to the 3 plus 3y to the 3 plus 4y to the 3. Now, you might say, oh, that's 7y to the 3. I got it. You don't got it. It is not 7y to the 3. Why isn't it 7y to the 3? I see a 3 and I see a 4. 3 plus 4 is 7. Therefore, it's 7y to the 3. That makes sense to me, right? Well, that's because you didn't think about something that we do in math that we don't really talk about, which is this right here. So as you can see, even though we didn't write it because we didn't feel like it, there is a 1. That 1 exists right here. We didn't write it out because we didn't feel like it, but it's always there. And we have a 1y to the 3 plus a 3y to the 3 plus 4y to the 3, which changes our answer from 7y to the 3 to 8y to the 3. So you see how something as simple as not writing your 1s out when you need to. So I would definitely advise that you write your 1s out. So if you see that, the first thing you do is you write a 1. Because otherwise you're gonna wind up leaving off a 1 when there's clearly a 1 in the equation or the expression. All right. One thing we can do is we can, if we're doing something like this, we can do several things actually. And let me actually work this out. Back and forth. Here. Yes, you can see that. All right, so this right here. I've got 4x squared minus 5x plus 3 plus 2x squared plus 2x plus 1. So I've got a lot of stuff that I want to start combining like terms with. So what I do is I basically go through and I say, okay, the exponent here is 2. The exponent here is also 2. The exponent here is 1. 1. That's it. All right. Then what I do is I basically say, okay, 4 plus 2 is 6. X squared, x squared, x squared. Notice I'm underlining my like terms. The reason I'm doing that is so I can keep things organized. I don't have to go back and remember what goes with what. You can also color code them. If you like shading and coloring things, you can color code them. You can box them, circle them, stuff like that. There's all kinds of stuff you can do to differentiate. Some people like to put like to circle things and box things. Another thing you can do is once you get something done, you can always just check it off like that, just so you know you're done with it. If you find that to be especially of an issue where you work a problem and you forget what you actually did or didn't do already, sometimes I do that, so I'll check something off and be like, okay, I've done that already, so now I'm going to go do this one. So minus 3x, check. Plus 4, check. So you see I'm labeling things. I'm kind of like, I'm differentiating things by drawing lines. This is 2 lines, so because of 2, 1 line because it's only 1, and this one it doesn't get any lines. So I'm doing that. I'm combining like terms just using regular math. I'm checking things off once I'm done with them. And then voila, I'm done. Now I would love to be able to take that 6, subtract that 3, and add the 4. I would love to do that. It would make my life a whole lot easier if I take the 6 minus 3 and make the 4, because I'll make less stuff. I can't. This is the most I can do right here. All right. So that's one thing to do. Another thing, just move down here, is I can go 4x squared minus 5x plus 3. And I can do 2x squared plus 2x plus 1. And I can stack them like so. I believe it's easy. I can stack them. If I stack them, then I can go, I get 6x squared, I'm plusing this, minus 3x plus 4. So if you like stacking, you can stack. Make sure that they're like terms on top of each other. So like you see this is squared, that's squared. This is not, that's not. So make sure you like terms on top of each other. But you know, you can always stack them on top of each other and do like that too. So there's a couple of ways of doing it. One not better than the other. They're equally as good. It's just whichever way makes the most sense to you. All right. Are there any ones here that don't need to do? All right, let's look at where am I here? All right. And you can kind of see what I did there. I stacked them. You don't have to stack them. You can. That's just something that might make it easier for you. If not easier for you, don't do that. All right. And again, I'm giving you another example of it. Let me just show you how you would do it without stacking. And you can look at the example with stacking. Lining stuff up. You know how to line stuff up. Cool. Let's just do that. All right. So this is another example. I've got 2x cubed. So I'll do 1, 2, 3. 3x squared. 1, 2. Nothing. 1, 2, 3. 1, 2. So now you see I have them differentiated. So now I can basically just go through and say, all right, this and that gives me 9x cubed. This and that gives me 7x squared. This and that gives me 15. Yay. All right, cool. All right. And you can also stack them. Let's look at subtracting. X squared. 5 minus 5x squared minus 3x plus 2. All right. When you subtract one polynomial from another, now I want you to notice there's a space here. It's a minus. There is a kind of in the middle of that, and again, this is one of those math things that we don't really talk about. There is a 1. Now, we're never going to write that 1 because we don't feel like it, and because we're not English majors, we're not here to write. But there's a -1 here. So what we have to do first, before we do anything else, before anything else happens at all, is that. Before anything else happens, none of this shortcut business, none of this, well, I'm just going to skip that step because it's boring. Before we do anything else, we're going to do that first. So, -1 times 5 is -5. -1 times -3 is +3. -1 times +2 is -2. So notice I haven't done anything else. All I did so far was just multiply just multiply -1 times everything. Now everything else just comes down like normal. And again, or you can stack them or something. You can always, you can do that. You can, and then you get -2x squared plus 5x minus 7. Or you can stack them like this: 3x squared plus 2x minus 5 minus 5x squared plus 3x minus 2. That also works. And then just do what it says. Go straight in your calculator. By the way, if you're going to do some more math, you should get a calculator, because calculators are really helpful. They make it really easy. They cost money. You have to spend money on them. It kind of sucks to spend money on things that you don't want to spend money on, but they do help you in math class. So, and if you're going to take more math classes and you want to do better in them, you need a calculator. So, your phone has a calculator. There are better calculators than your phone. All right, but let me go back up here again. Let me talk about this. Before we did anything else with this situation, the first thing we did was we distributed the negative out before we did anything else. All right, then I went ahead and underlined all my terms, differentiated them. If I want to, I can go through and check mark them. I did that one, yay. And that's it. Let me see. Am I continued? I am continued. Here we go. I'm sure I have another example. All right, those are just some, okay, those are your rules. If you forget your rules, those are your rules for basically multiplying numbers together. I just put that in there just in case you forgot those. Those are important. Your calculator will do all these for you if you just trust your calculator. All right, distributive property, which we just did. That's distributive property. That's a summary of it. Blah, blah, blah. When you subtract polynomials, you gotta make sure and multiply things out. We have to remember like terms and unlike terms. You can only do like terms. You can only add and subtract like terms. I'm not gonna go into the next section because it's a little bit different, and I'm not gonna go there yet. I'm gonna kind of give you a chance to look at this and kind of ruminate on this, and you can kind of see what like terms look like and what unlike terms look like. Where's my mouse at? Here it is. These are like terms. Those are unlike terms. These are like terms. X squared, X squared, X squared, and X aren't like terms. All right, you cannot add or subtract terms if they're unlike terms. All right, combine like terms, you can rearrange things. So you can put them together like that. You can underline them like the way I did it before. I prefer underlining. You can rearrange them. Rearranging them is a little dangerous because you might wind up moving something. You might change the sign on something. So I wouldn't rearrange things. I would either underline them or I would stack them. Stack them is another really good way of doing it. Stacking them is pretty good too. All right. Remember, distributing is multiplying, combining like terms adding and subtracting. And I'm going to send you, so that's pretty much it. That's all I have. Let me